Welcome everyone. I'm Chen Goldberg, EVP of Product Engineering at CoreWeave. This has been one of those months where I'm reminded why I love being an engineer. CoreWeave, in partnership with Dell and NVIDIA, became the first AI cloud provider to bring up and validate NVIDIA Vera Rubin NVL72. That was a big milestone. Getting here was not easy, but it was also really fun. But before I tell you how we got here, let me start with what a phenomenal technology NVIDIA has actually built here. Vera Rubin is not an incremental upgrade. 72 Rubin GPUs, 36 Vera CPUs, 260 terabytes per second of NVLink 6 bandwidth inside a single rack, which is more data bandwidth than is used by the entire global internet. This is one of the most impressive feats of engineering I've seen. And it's arriving at the right moment. The world is shifting from asking AI questions to having AI actually do things continuously, at scale, without stopping when you close your laptop. Agents writing code, running experiments, and executing multi-step reasoning loops. That is exactly what Vera Rubin was architected for. It is a disaggregated, distributed agent processing system. When your product is an AI agent, every token you generate has a cost and business impact. Vera Rubin delivers 10 times better inference throughput per watt and 1/10 the cost per million tokens versus Blackwell. That is way more than a spec sheet improvement. That's a technical leap. Now let's talk about customers, because the engineering feats only mean something when you connect them to actual work. With CoreWeave's new innovations and full stack optimizations for Vera Rubin, customers can train models more efficiently, accelerate inference, scale autonomous AI, and achieve a lower cost per token. The bottleneck on innovation isn't ideas. It's the pace of experimentation, and that pace is constrained by capacity. So when an efficiency leap like Vera Rubin compresses the cycles from days to hours, you're not just saving money, you're changing how many experiments a team can run, which changes how much their business is impacted. Performance and efficiency are crucial. In the recent MLPerf 6.0, we set new records for benchmarking the largest NVIDIA GB300 cluster with over 8,000 GPUs, and we trained DeepSeek V3 with 671 billion parameters in 2 minutes. With inference, we also delivered leading results with DeepSeek and GPT-OSS. This is why customers such as Anthropic, Cursor, IBM, Jane Street, Meta, Mistral, and OpenAI rely on CoreWeave for performance, reliability, and efficiency. Getting customers to run their AI innovation reliably in production, not just on a benchmark, is where our real engineering work lives. When we look at a technology leap like this, we spend a lot of time on the drawing board, anticipating the bottlenecks and constraints posed by existing solutions. And we get down to innovating around new solutions that will make it easier for the infrastructure to work the way it is supposed to for our customers. With Vera Rubin, we added 2 new innovations to CoreWeave Mission Control. First, Vera Rubin is 100% liquid-cooled, so we added more sensors and telemetry at the per-rack level. We call the system Valve, a programmable per-rack valve assembly which turns cooling from a passive mechanical system into a software-defined rack-level control surface. Valve controls and monitors each rack flow rate, temperature, pressure, etc., to keep the rack operating at optimal state. We also engineered Racky, our unified rack manager, designed to provide centralized control and observability per rack. Racky works with multiple systems, including Valve, and aggregates power, cooling, and environmental sensor into a standardized management surface, allowing each Vera Rubin rack to be managed as a cloud resource. You'll hear more about Racky and Valve throughout our event today. We also deployed the liquid-cooled Spectrum 6 Ethernet switches and will provide multi-rail, multi-plane networking for Vera Rubin. We will support both NVIDIA Quantum X100 InfiniBand and NVIDIA Spectrum X Ethernet with Racky, delivering 1.6 terabit per second of backend bandwidth per GPU. The Spectrum X Ethernet architecture scales to over 120,000 GPUs. We optimized every layer of our stack, and that includes CKS and SUNC. CKS is NVLink domain aware, so it places workloads on the NVLink fabric to minimize traffic crossing scale-out interconnects. Sync is a topology aware and schedules workload on the most efficient GPUs while minimizing inter-rack communications for lower latency. I spent time on the floor at our data center, where our hardware engineers are working alongside the NVIDIA team. What stood out was how intentional the move to rack-level management was. We thoughtfully leaned into Vera Rubin rack scale architecture without compromising the granularity we need to operate every component underneath it. I'm very proud of that work. I will wrap up by noting that we are living through one of the most significant transitions in the history of computing. What we build today becomes the foundation that everything else runs on. Thank you, and I hope you'll join me for our deeper dives.